SwayamPrabha. Digital India. Educated India.
Good morning, dear friends. I welcome you for this course titled Introduction to Airplane Performance. And you could see that I am standing inside our flight lab hangar, which is one of the unique facility of IIT Kanpur Aerospace department. And you could see that I am surrounded by so many aircraft. This is the pride of India, the Hansa 3 aircraft, designed, built and fabricated by National Aerospace Laboratory in association with so many private companies, one of them Taneja Aerospace. And you could see there that plane is Cessna 206. It is named as Station Air, wonderful aircraft. And further there, you could see this is a motorized glider, which is Sinus 123. And we have such more aircraft here, and I'll be showing you those aircraft as the lecture progresses. But what is our basic aim for this course? The basic aim is, if we see this airplane, Hansa 3 aircraft, there is the engine. Incidentally, it has Rotax engine. As I switch on the throttle, the propeller rotates, it generates thrust, so it gives it a forward velocity. But what is more important, that I need to generate lift. We should lift the aircraft upwards, and for that we have, this is the wing, large, huge surface, where when the pressure acts beneath this wing surface, it generates lift, and we cruise. Okay, and we'll be explaining what exactly we mean by cruise. And if we see at the end, if I come along with me here, you could see there are control surfaces which are deflected as and when required to turn the airplane right or left, like this. And similarly, we have here elevator. It's also a control surface which is used to pitch up or pitch down the airplane. And similarly, we have right here, which I can turn this way or that way to turn the airplane towards right or towards left. All this will be explained in this course by one of our quality control manager, Miss Rekha. We will find one module will be dedicated for this part only. What is our basically aim? We would like to know, how do I utilize this area to generate lift? Okay. Now we will go back the olden times when George Cayley gave us this idea that if I put a flat plate at an angle of attack, that is, I move the flat plate like this, and the pressure acting on the lower surface will be responsible to not only generate lift, but also it will try to drag the plate. So we need an engine to overcome that. All this detail will be now discussing in the classroom. At the same time, do not forget, this is the cockpit. There will be a dedicated lecture on the cockpit, where you'll see what are the instruments available in the cockpit, which helps the pilot to know what is his status, what is the speed with which he is flying, what is the altitude he is flying, what is the bank angle he is flying, what is the throttle level. All these details, engine details he will be getting, so that he is comfortable and use all the information to complete a mission requirement. Right? Thank you. So now we go back to the classroom and we will start asking a question: how does an airplane generate lift, and how manage this lift for our useful purpose? Right? Before we go to the classroom, let us have a closer look on the wing structure. If you see this portion, we call wing leading edge, and the shape of the wing is decided by these ribs, which forms very important part of the wing, and we call it aerofoil. Right? If I take every cross section, I'll be seeing a shape like this. and depending upon the cross section, the quality of lift will be dictated. And you could see that here there is a strut. This strut is because to support the weight of this wing, and one of the important aspects once you put a strut is that okay, it is fine, it will withstand or take the load of the wing, but same time it should not create drag. So you could see that even the covering of this strut is having an aerofoil shape. Okay? So aerofoil shape and knowing about aerofoil will be extremely important when you talk about airplane performance. Also, you could see that these are the landing gear, and they are not retractable type. We have Piper Saratoga where the landing gear goes in. So once it is flying in air, landing gear is out, then that offers a lot of resistance. So that is unavoidable for such airplane, but for bigger airplane or even for Saratoga, what happens the moment I take off, the landing gear goes in, so the drag part is reduced. So we have aircraft where we have got a fixed landing gear, we have got a retractable landing gear with the purpose that once we are cruising, I want to fly at a drag minimum, so I prefer that the landing gear should be taken inside the belly of the fuselage so that overall drag reduction is there. Right? You could also see this is a Piper Saratoga airplane. Here, in the other airplane, you have seen the part of the surface moves as an elevator, but here the whole tail moves as an elevator. So this is called all movable tail. So you will have two types of airplane, one in which part of the surface moves as elevator, unlike other airplane, this airplane Piper Saratoga, where you will see, you have seen that this, as I was mentioning, this is the whole tail moves as an elevator, unlike the other airplane where part of the surface moves as an elevator. So these are the basic important points we need to know before we start discussing about the airplane, how does it fly, how does we control an airplane. So now from here, we now go back to the classroom and keep back of your mind two important things when I am talking about wing, that wing and aerofoil, they have got an implicit relationship. A good aerofoil will ensure that a wing is highly lift effective. So we'll be starting from this in the next session.